Hello, everybody. Can you hear me? Okay. Today I'm going to tell you how reconciliation loop works in Kubernetes in visual representation. My name is Andrei Kvapil, and as about reconciliation loop, this is main pattern how Kubernetes works, and it is used anywhere by any operator, by any controller. Let's see at Kubernetes scheme first. We have Kubernetes API server. It should store data somewhere. Mainly it stores data in etcd, and there are a few more binaries, few more controllers, kubescheduler, controller manager, kubeproxy, and kubelet. They're controllers, and there's API server. API server stores all the information about Kubernetes resources, and controllers are working with them. Actually, they're just subscribing for all the type of resources, and let's see how it works. We will show example how we can start pod and how various controllers, kubescheduler and kubelet, they are also controllers, works with this pod. First, what they do, they run watch for this type of resources, and they subscribing for this. So they use long polling model, and this resource is just connecting, transferring from kube API server to those controllers. We can also simulate controller by running kubectl get pod with W key, and we will the same subscribe and see the same every iteration which is happening with the pod when we trying to start it. In another console, we'll try to create another pod. We just run kubectl create this spec. First, this pod arrived to kube API server, and the API server appends creation timestamp and status, and we see the next iteration. So scheduler finds that there is a pod, it has no node name, I have to assign node name. Then it runs its own reconciliation loop, its own business logic, and assigns node name to the same resource. Then kubelet on the same node, node 1, sees that there is a new pod assigned to this node, and we have to run containers on this node. So it starts running those containers and continuously reporting the state in the same YAML resource, the YAML manifest, described in API server. When pod is created, we see a running state, nothing is happening until you will decide to delete this pod. When you delete this pod, your request arrives still to kube API server. It assigns deletion timestamp, and the same logic is running for the rest controllers. First, kubelet finds that there is deletion, pod expecting deletion, starts shooting down the containers, continuously reporting the state back to the Kubernetes API server. And after all the containers removed, it removes the pod exactly from Kubernetes API server. That's it. Thank you. That's all I wanted to show you.